For question 3a, a carbon wire of length 100 meter having a uniform cross-sectional area of 3 exponent negative 8 meter squared and resistivity of 3.5 exponent 5 ohm meter is used in winding a heating coil. Determine the resistance of the carbon wire. So resistance is R. Given from the question, length of the wire is 100 meter. Cross-sectional area of the wire is 3.0 negative 8 meter squared, and resistivity of the wire is 3.5 exponent negative 5 ohm meter. Then use equation R equal to rho L over A. So substitute all the information given. Substitute rho, resistivity. Length of wire is 100 meter and the area or cross-sectional area. So calculate, we get R equal to 1.2 exponent 5 ohm. 1 mark will be given on GJU. Gantian jawapan and unit. For question 3b, figure 3.1 show a battery connected to a resistor R. The current flow is 2 ampere when R is 2 ohm and 1 ampere when R is 5 ohm. Determine the EMF of the battery and its internal resistance. From the question, there are two conditions, value for I and R. First condition, when I equal to 2 ampere, R is 2 ohm. Second condition, when I equal to 1 ampere, value of R is 5 ohm. Then determine the value of EMF and internal resistance. To solve this problem, we use equation EMF equal to I times R plus internal resistance. Okay, substitute all the information given for the both condition. So for the first condition, EMF equal to 2 times 2 plus R. So rearrange, we get EMF equal to 4 plus 2R. So let's say this is the first equation. For second condition, we substitute EMF equal to 1 plus 5, 1 times 5 plus R. So rearrange, we get EMF equal to 5 plus R. So let's say this is the second equation. So by equating equation 1 and 2, we get 4 plus 2R equal to 5 plus R. Then calculate, we get R equal to 1 ohm. Okay, so settle for internal resistance. Then to find EMF, we can use either equation 1 or equation 2. So let's say we use equation 1. So EMF equal to 4 plus 2R. Then we substitute R equal to 1 ampere. So we get EMF equal to 6 volt. Okay, there are 4 marks in this question. First mark is gantian 1 for first equation. Second mark is gantian 2 for second equation. Third mark is when we calculate the value of R. So we get R equal to 1 ohm. So 1 mark. Jawapan unit 1 mark. And the fourth mark when we calculate EMF. So we get EMF equal to 6 volt. So jawapan unit 1. So total is 4 marks for question 3B. For question 3C, figure 3.2 shows a potentiometer with a slide wire AB of length 1 meter connected to a driver cell of EMF E1 2.4 volt with negligible internal resistance. The balance length AC, so here is point C, is 0.7 meter when the switch is open and 0.6 meter when the switch is closed. So determine first EMF E2 of the cell, and second the current I and its internal resistance. So there are three questions we have to find. The first is EMF2, current, and internal resistance R. Okay, from question we know that LAB equal to 1 meter, E1 equal to 2.4 volt, LAC is 0.7 meter when S is open, and when S is closed, LAC is 0.6 meter. Okay, for question 1, to find EMF or E2 when S is open, we know that VAC equal to E2. VAC equal to E2 when S is open. So use the tabulation method. For VAB equal to E1 is 2.4 volt and LAB is 1 meter, and VAC equal to E2 where the LAC equal to 0.7 meter. So from the table, we know that VAB over VAC equal to LAB over LAC. So substitute all the information about VAB is 2.4 volt, LAB is 1 meter, and LAC is 0.7 meter. So calculate, we get VAC equal to 1.7 volt. We know that VAC equal to E2, so E2 equal to 1.7 volt. Okay, so for this question, the mark is 3. So first mark, when we know that VAC equal to E2, that is mark for concept. Then second mark is gantian. When we substitute the value of VAB, LAB and LAC correctly, we get 1 mark for gantian. And the third mark is answer for E2, 1.7 volt. Is jawapan unit 1 mark. So total 3 mark for 3C1. For question C2, when S is closed, we know that R equal to 3 ohm. So VAC equal to IR. So use the tabulation method. So VAB equal to 2.4 volt when LAB equal to 1 meter. And when VAC equal to IR, so LAC equal to 0.6 meter. From the table, we know that VAB equal to VAC, VAB over VAC equal to LAB over LAC. So substitute value for VAB is 2.4 volt, LAB is 1 meter, and LAC is 0.6 meter. So we get VAC equal to 1.44 volt. Since we know that VAC equal to IR, so I equal to VAC over R. So substitute the value for VAC 1.44 and R is 3 ohm. Calculate and we get I equal to 0.48 ampere. To find internal resistance R, we apply equation E2 equal to I times R plus internal resistance. So substitute the value for E2, which is 1.7, we get from C1. I is 0.48 and R is 3 ohm. Okay, so calculate, we get internal resistance R equal to 0.54 ohm. So for question C2, there are 4 marks given. First mark is gantian for VAB, LAB and LAC. So gantian 1. Second mark is answer for current. When we calculate and get current equal to 0.48 ampere, we get 1 mark for jawapan unit. Third mark is gantian for E2, I and R. So gantian 1. So E2 1.7, I is 0.48 and R is 3 ohm. We get 1 mark. And fourth mark we get when we calculate R, internal resistance, is 0.54 ohm. So jawapan unit 1. So there are 4 marks for C2 and total mark for the question 3 is 12 mark.